Hello and welcome to the second video of the FP1 chapter Coordinate Systems. On the screen, a starter to help you review an idea that we will use in this video. Draw the locus of points equidistant from A and B. Pause the video and give this a go now if you've got time. So remember that the locus of points is a set of points that all follow a given rule. In this case, the rule is to be equidistant from A and B. The first obvious point is if you connect A and B with a straight line and you go halfway, is about here. But then you can go off that line over here, and then you can see that this would create an isosceles triangle, this distance same as this distance, and you can keep going and in the other direction. And if you do all of the points in between as well, eventually you find that you've just got one long straight line of an infinite number of points. And we'll use this idea of loci later in the video. So we've done a quick introduction to parametric equations. In this video we're going to focus on parabolas, one of the curves we met in the previous video. We're going to look at the equation and something called the focus and directrix. Then near the end there's an additional example that is between exercise 4b and 4c, so I've just put that in at the end of this video. In the next video, we'll look at rectangular hyperbola. Here we go with parabolas. So we did see the general parametric equations in the previous video for this curve here, which is a parabola, and they were x equals at squared, y equals 2at, where this a is just a positive constant, depending on the specific curve we're looking at, and t is just a real number. We also saw the Cartesian form, that you could rewrite this as y squared equals 4ax, but a parabola can also be defined as a locus of points, and that's where we get this 4a coming in. So let's have a look at that. A parabola can be defined as a locus of points P that are equidistant from a point, which we call the focus, I'll call that S, and a line, which we call the directrix, and I'll call that D. So instead of 2 points like we had in the starter question, here we've got a point and a line. And a parabola is defined as the points equidistant between these two. And again, we have a really easy starter point. If I say from here, this point on the line, to here, the midpoint, that's pretty easy to find. But as we move along this line, it's not quite so obvious how that works. I don't just choose a connecting line like this. What I need is equidistant from the line and the point. And if I quickly show you why I'm not going to do this, if I did that and went halfway there, and now I would say, oh wait, actually, this distance to the line here is shorter than the distance to the point. So what I need to say is the perpendicular distance to the line should be equal to the distance to the point. And if I do that, it's more like here, where these two distances are the same. So we're calling the point the focus and the line the directrix. And here is a better drawing of what I was trying to do. P in the middle here is a point that is equidistant from S and equidistant from D, where we're considering the perpendicular distance to the line. And if you find all of the points on the page where this is true, and you get your locus, it looks like this, which is our parabola. And every point on this curve follows that rule, that it is equidistant from S and D. So P to S and P to D is equal. And if I go over here, the distance P to S here, and the perpendicular distance from the line would be equal. Then if we take all of this a step further, and we put it on an XY grid, like this, so that this point here, the vertex of the parabola is at the origin, so forcing that vertex to be at 0, 0 gives us a very interesting point for S, the coordinate A0, which is why our A comes up in here. So the distance from here, the vertex, to the focus, the distance that we're using, has an effect on the equation. If we bring this further out, then it's a much bigger distance, and the curve goes a lot shallower as it comes around. And if we bring it closer in, then as the parabola comes around, it comes around more like this. So that has an effect. And of course, because from here to here at this point must be equal the distance from here to here, then we know the line of the directrix D must be x equals minus a, where this is the same a coming into the equation. So if you know that constant a, you know the coordinates of the focus, you know the equation in Cartesian form, you know the equation in parametric form, and you know the equation of the directrix. Basically, you know everything if you know the value of a. And that's really useful, particularly as any one of these, if you know what they are, you can work out a and then work out all of the others. For example, if you know the focus is 7, 0, then immediately you can create this equation and the directrix. But if you know the directrix, then you can do the same. You can create this equation and write down the focus. So our first example is going to be doing this. Find an equation of the parabola with focus 9, 0 and directrix x plus 9 equals 0. So immediately both of these bits of information tell us that a is equal to 9. So an equation of a general parabola is y squared equals 4ax, and if a is 9, then this becomes y squared equals 36x. And that is the equation of the parabola with this directrix and this focus. Part B, same idea. If the focus is root 5 over 4, 0, then a is equal to root 5 over 4. And you could say the same thing about the directrix. This is telling you the same information. So the equation, the general equation, is still y squared equals 4ax, and if a is root 5 over 4, then this becomes root 5x. The next example does this backwards. It gives us the equations, y squared equals 20x, and we're asked to find the coordinates of the focus and an equation for the directrix. But it's the same idea. If we compare this with y squared equals 4ax, then we can see that 20 must equal 4a, so the a value must be 5. And once we know that, we know the focus is a0, so it's 5, 0, and the equation of the directrix is x equals minus a, so x equals minus 5. Same idea for part B. Y squared is equal to 4ax, and if that is equal to root 32x, then we can say that 4a must equal root 32. A quick bit of calculation, 16 times 2 is 4 root 2, so a must be root 2, which immediately tells us that the focus is root 2, 0, and the directrix has equation x equals minus root 2, or you might sometimes see it written as x plus root 2 equals 0. So questions like this are quite straightforward, but a question like this requires us to prove something. So a point P, xy, obeys a rule, so this is telling us it's a locus, such that the distance of P to the point 6, 0 is the same as the distance of P to the straight line x plus 6 equals 0. So straight away from the context of the question and the information it's given, we know it's a parabola with a equals 6. But we need to prove that the locus of P has an equation of the form this, stating the value of the constant a. So what we've done so far is to say that it is this, and a is 6, but now we need to prove it. So to help us do this, I'm going to bring that diagram back. This was the diagram we had before, where P to S must equal P to D, and with the general coordinates x, y, we can make a little triangle here to find PS squared is equal to this side squared, which is just the y coordinate y, so y squared, plus this side squared, which is the x coordinate of S, 6, minus the x coordinate of P, which is x. So the distance along here is 6 minus x. Just do a bit of Pythagoras there, and we get this equation here. Now we know that PS must equal PD. That's the whole point, is that it's equal distance. And they're telling us that in the question as well. So that also tells us that PS squared would be equal to PD squared. And the reason that's useful is because I don't really want to have to square root all of this to get PS. It's much easier to just find PD squared and make them equal. Because PD squared is just this distance here, squared. And we know this distance here because this from here to here is 6 units plus the x-coordinate of P, which is x. So PD squared is equal to 6 plus x all squared, because PD is equal to 6 plus x. So now, using this relationship, I can make these two equal, and we have an equation in y and x, which hopefully will simplify to this. Expand this out, we get 36 plus 12x plus x squared, and over here y squared plus 36 minus 12x plus x squared. And you can see very quickly the x squareds cancel, the 36's cancel, and if I rearrange, we get y squared is equal to 24x, which of course is 4 times 6x. Make it really clear there that this relates to the y squared equals 4ax, where a is equal to 6 as we expected from the information given in the question. So this relies on a bit of Pythagoras and this relationship here. So at this point you could stop and do exercise 4b, but between 4b and 4c in the textbook there's only one small example, so I've put that at the end of this video here. It looks like a big example, but each part is not too bad. The point P, 8 minus 8, lies on the parabola C with the equation this. And remember that immediately tells us the A value. The point S is the focus of the parabola. The line L passes through S and P. So P is on the parabola, S is not on the parabola, it's the focus, but the line goes through both of them. So to find the coordinates of S, all we need to do is what we did before, compare this equation with the general equation for ax equals y squared, and we can see straight away 8 equals 4a, so a is equal to 2, and that tells us the coordinates of the focus to 0. Part B, find an equation for L, giving your answer in this general form here, with a, b, and c as integers. This now is quite straightforward as well, because we know L goes through P, and it goes through S, so we have 2 points. All we need to do is find the equation of the line that goes through those 2 points. This is effectively a GCSE question. So we have P8 minus 8 and S2, 0. So the gradient is y1 minus y2 over x1 minus x2, so it's minus 4 over 3. Put that into our straight line equation. Y minus y1, I'll take the s coordinate, is equal to m x minus x1. So we have y is equal to, let me multiply by 3 there as well. 3y is equal to minus 4x plus 8. So in the form they want, we've got 4x plus 3y minus 8 equals 0. And that is the equation of L that goes through point P and point S. Okay, we've got those two things. I've put them up here. Here's the equation for L. Here is S. We still know P and the equation of the parabola. So now the line meets the parabola C again at the point Q. The point M is the midpoint of PQ, and we have 3 new questions to answer. But to do this, I would instinctively draw a diagram to help me understand what's happening. And I know that comes up in part E, and I'm going to do most of E before we get there, but it's just part of my problem solving process that I like to see what's going on. So we've got a parabola that looks like this. We've been told the focus is here, and P is 8 minus 8, so that's further along the x-axis and way down on the y-axis, so it's down here somewhere, and that's on the parabola. The line L goes through these 2 points, so it looks, a terrible straight line there, but it looks kind of like that. So here, what is Q? Q is the point where L meets the parabola C again. So it meets the parabola C down here, and it meets it up here. So Q must be this point up here. And this is the point they want to find the coordinates of in part C. Then the midpoint of P to Q is kind of around here. I don't know how good my diagram is. It may be lower than S or it may be higher than S, but it looks like it's going to be lower. So around here somewhere. And part D, we're going to find those coordinates as well. And in doing this problem solving process, just to have an idea of what it is that's going on, I've effectively finished part E, because I've shown the parabola, the line, and the 4 points where I think they're going to be. When we get to part E, I'll just check that the coordinates match the 4 points I've got here. So we need to find the coordinates of Q. To do that, we are trying to find where the line meets the curve, and you know from previous work that we just need to make the two equations equal one another, or substitute one into the other. Here we have y squared equals 8x for the parabola, and this equation for the line, so we need to either make them equal or substitute one into the other. What I'm going to do is I'm going to make x the subject of this. So we've got 4x is equal to 8 minus 3y, which makes x equal 8 minus 3y over 4. And then I'm going to substitute this expression for x in here. So we've got y squared is equal to 8 times x, and x we now know is 8 minus 3y over 4. And tidy this up a little bit. That cancels with that, gives us a 2, so we've got 16 minus 6y. And then remember why we're doing this. We're trying to find the coordinates, so I need to solve this now. And this is a quadratic in y. Can we factorize this? I think yes. We have a plus 8 and a minus 2. So y is equal to 2, or y is equal to minus 8. Now where the curve meets the line, we know that one of those points is P, and the coordinates of P are 8 minus 8. So this one here, this is P. And this one here is the y coordinate of Q. And I also need the x coordinate of Q, so I'm going to put that back into this expression here. So x is equal to 8 minus 3 times y, which is 2, so that's 6. 8 minus 6 is 2, divided by 4 is a half. So the coordinates of Q are a half and 2. Part D then becomes quite straightforward. Find the coordinates of M, the midpoint between P and Q, so long as you can remember how to find the midpoint of two endpoints on a line segment, you're okay. To do that, we find the x coordinate by finding the average of the endpoint x coordinates, x1 plus x2 over 2, and the same for the y coordinate of the midpoint. We just average the y coordinates of the two endpoints. And I know the two endpoints. We know Q is this, and we know P is this. M is 8 from here, plus a half, 8.5, or 17 over 2, divided by 2 is 17 over 4. And the y coordinates, minus 8 plus 2 is minus 6, divided by 2 is minus 3. So the M is roughly in the right place here. The y coordinate is a minus 3, so it's definitely below the x-axis. And I think that's just about it. We found Q, we found M, and as part of my process of doing that, I've already done E, sketched it here, indicating the points and the line and the parabola, although my line is not very straight. And there we go. That is enough now to also do exercise 4C. And maybe I'll see you in the final video for this chapter.